Hello, everybody. It's Dr. G, and welcome to the second video in our series of understanding how to complete data analytics, specifically using the Titanic database in both Excel and in Python. So we're going to get started today looking at the concept of correlation. So in order to get started, make sure that you have your laptop handy and that you have access to Canvas. So let's get started. I'm going to share with you my screen. And there we go. So what you're seeing here is the assignment number 5, Titanic database analysis, that is located in module 11 of Canvas. And as you scroll through and read the instructions, there's a number of materials I want to point out that I pointed out in the last video. You have the Titanic database file, and with that, you also have the code book, which is located right here. And the code book has the information about the passengers who were on the Titanic that sank tragically on April 10th, 1912. So there's a number of different variables, there's descriptions of what they mean, and codes for you to understand for which we are going to run statistics on. So we're going to analyze, last time we were together, we analyzed descriptive statistics using Excel and mainly pivot tables. Now we're going to log into the correlation analysis, and I want you to click on this correlation workbook right here, or you could go into module 11 and all of the data that you need is also at the bottom of the module. So if you scooch down here, you will see, well, number Titanic lecture information. So let's click on the analysis. What I want you to do with this particular worksheet is, as always, I want you to go ahead and it's a little bit hard to see here. I'll make it bigger. I want you to make a copy of that and save that wherever you're going to like. I'm going to make this called a test video. There's my copy. That way you're not going to be overwriting all the good work I have on creating that template. So that's where we're going to start. For the Titanic, as you recall, there are 3 activities you need to do. One is the descriptive worksheet, which includes descriptive statistics, means, modes, all those great things in pie charts, all those great things, but you're going to be doing it in pivot tables, and that is going to include the worksheet as well as the Excel file. You're going to upload both of those. In addition, to complete the assignment, you will upload this worksheet we have here called correlation, and the one we will do in the next video, which is logistic regression. So you will have the data file and 3 worksheets uploaded into one assignment. So let's get started here. We are going to attempt to look at the correlation of variables between information that we know about the people who lived and died, the passengers on the Titanic. So just like we did with descriptive statistics, I want to make sure that you download the data file titanic.csv. And so you're going to do that with this particular in the assignment. Let's go back to the assignment, or down below. It's this file right here, the Titanic CSV file. So you're going to download that into a place in your download files on a particular drive, etc. Now, the important thing about this is after we download that file, we are going to go into a program. Sorry, this little bar is in my way. We're going to go into a program called Colob.google.com. Before we do that, make sure that you have uploaded that Titanic.csv file into my drive right here, my drive. You're going to take the new, you're going to file upload, you're going to find that document, probably in your downloads, right here is where mine is at, and you're going to load it into your Google Drive and note the path. Now, it's really important that you place it into my drive because that is how we have the Python code coded to recognize where that file is. Once you have done that, now I want you to go into the website called Colob.google. Now, this is a great repository that we can use to host Jupyter, which is a name of Python. So you are going to go in here and open a new notebook. Now you will see this is the workspace we're going to be using. And right here, the name, it gives you an untitled name with a peculiar ending here. Some Python thingy. So let's call it something. I'm going to call this test correlation spring 24. Now I suggest, as I did in the worksheet here, that you call it Titanic _ correlation. I have way too many files in my workbook that I'm just going to call it something else. But you call it that, name it. And so what we have here, you're going to have that name. This is your file name for your notebook in Colob. The next thing we're going to do is analyze this. So right here, this is where your Python code is going to go. And it has a little run button. So our purpose here is to copy the code we need for each of the tasks into Python to run. And the first thing that we want to do is we want to import the Python libraries. So this is where all of the good data is stored in running those statistical models that we're interested in looking for. In this case, particularly for linear regression, for correlation, descriptive statistics, things like that. So you're going to copy this right where I have it, copy right there. And then you are going to paste this code right into the code box. Once you have pasted that, run the little triangle button there, and you will know if it works because it will give you a green checkbox. You did it right. Yay, you won. Very good. Now, what we need to do is we have more things to find out. This loaded the libraries from Python. The next thing we need to do is we have to tell Python where our file is located. And remember, you downloaded that file to your Google Drive. So let's go back to my handy dandy worksheet here. The next thing we're going to do is we are going to create, copy the content right here, the code. And what I want you to look at here, what I have highlighted here in between these little I don't know what they're called, little symbols there. They're not quotes, it's a singular quote. This has to be the file path of where you place your Titanic file. Now, if you followed my directions and placed it in your My Drive, this should work. If it didn't, we have to chit chat and work through that. Okay, now you're going to go to this new code spot that we put, and we are going to paste it there. And let's hold our breath and click the run and see if we get a cool green check mark. Oh, look at this. It is asking us to connect to our Google Drive. This is a good sign. So we're connecting to our Google Drive. There I am, Dr. G. Keep on continuing on, keep on keeping on here. And then we showed it where it is. Asked us where to find it. It's searching for that file. If I do not get this to render the file name is incorrect, the file path. But you will see I got a little check mark there. And then the code that I've placed in there allows you to see a snapshot of that CSV file. So you can see, yeah, look at everything seems to be rendering fine. There are some things here. There are some blanks. There's ones and zeros. Those are our binary variables. But it gives you an idea that, yes, it has loaded in and it's getting our data. Okay, so you're good. The next thing we're going to do, click on code again. So after we've done that, we're going to go back to our handy dandy worksheet here. Now, what I want you to do now is to interpret some data. So the first thing we are going to look at is ticket class inspection. So as you know, sometimes there's all kinds of urban legends about everything. And in terms of the Titanic, which isn't an urban legend because we have actual data, people say that there's a difference in survival odds based on the level of class you are. You know, like if you're sitting in first class in the airplane, everything's all fancy and you get the free drinks and the food. And if you're down below, like in the back of the plane, you get nothing. Well, think about that in the Titanic. The people in third class are at the bottom of the ship, and then there's the second class in the middle, and then the first class, they're the ones atop, the nice cabins. So we want to see, is there any correlation between their ticket classes and whether they survived or not? So we are going to go in and copy my code that I have here. Let's go back into your Colab, and we are going to paste it in the code box and run again. Ah, look what popped up here. Hey, this is cool. So it's rendering us a counting plot. And you can take a look and try to interpret what this means. So remember what I said, the legend or the data infers, or what people talk about on the news or did back in 1912, is that more people who were in the third class died than survived compared to the other classes. So the theory is there's a socioeconomic theory in here that says the more wealthy you are because you can afford that class fare, the less likely you are to die. So let's look at this. Is our first class passenger, I don't know what they call it, level, first class level. The zero is unfortunately you passed away. The one is, yay, you're a survivor. So up first class, you have more survivors, about 150, compared to about 75 people who pass. So your chances, your odds on first is you're going to survive rather than not survive. Now in second class, sadly, there's still fewer people in second class, but just a smidge more died than lived. Now look at third class here. You got a whole bunch of people who passed away, and even less than first class survived. Even though the numbers are greater, there's far more that passed away. So that is what you're going to interpret what the meaning of this is. And what I want you to do is to take a screenshot of your plot here and copy it into the handy dandy book here. And so it says, copy and paste your results from Python here. I'm going to go to the next page and I'm going to paste it in there. Yeah, this is all Google Docs doesn't like copy and paste the old fashioned way. So that said, I'm going to paste it here and then I'm going to interpret the initial counts, just like I just described to you. What is the meaning of this related to passenger class and whether you survived or not? So that's what you need to do. Type in the box your interpretation of the graph. You're done. You're done with part of it, not the whole thing. We got a long way to go. So that's the first part. The second thing we want to look at, just to kind of get an idea of our data, and again, these are descriptive statistics here, is we want to look at adult males, because remember, we always hear women and children off the ship first. You get into lifeboats, everybody, all the men have to wait, no sneaking in line. So that said, let's take a look at adult males, considering we're thinking they're the last ones off the boat and how their survival rate is. Okay, so I'm going to take my code here I'm going to copy, go back into my Colab document, Colab, I don't know what it is. Add a code box, paste it in there, and run. Voila. We have another graph here. And our graph here, take a look at this. These are all adult males. So when you look at your handy dandy code book that you downloaded, you can look at what does adult male mean. Adult male means a binary variable. Binary is 2, one or the other. 0 is true, or 0 is false, and 1 is true. So false would mean they are not an adult male. True would be, yes, indeed, they are an adult male. The other thing we wanted to look at, like we did last time, is survival. 0 means they did not survive, and 1 means they survived. So you can take an eyeball chart here and go, okay, so we're not really going to look at those people who were not males. I guess we could. But if you are an adult male, you have a very, very high percentage that you are not going to survive. If you are not an adult male, maybe you're a child or a female, you have a greater chance of surviving. So that is how you would interpret the counts of adult males versus everybody else in their survival rate. So I am going to copy, whoops, I don't want to do that. I want to copy this. Oh shoot, did I just mess that up? I hope not. And then I'm going to go back into my worksheet here. Where am I? Wrong one. Okay, so I am going to paste my output. Yeah, you gotta love that. Can't paste the old-fashioned way. Gotta do me more work. Okay, so you pasted the graph here, and now what I just explained to you could be your interpretation. You might have a different interpretation, but what do the statistics mean to you in terms of survival rates of adult males or others? Okay, so now let's get into the nitty-gritty of what we're really interested in understanding, and that is correlation. If you remember from our lectures, correlation is basically the relationship between variables or things, what you want to measure. So we are going to look at relationships, associations between 2 or more variables. So in our case, what we have to do is we got to get Python up and running here because there's a few things we need to do. We have to tell it some things. We got to get it ready to understand what we want to do. So we're gonna talk correlation here in our code. So you're gonna copy, whoops, paste. I pasted. What we're doing here is because we have a database that may not have all the records of who lived and died or other variables, we have to tell Python that we want to eliminate or ignore the nulls or those that are blank. This is the beauty of coding. We couldn't do this in Excel without cleaning the heck out of our data because we're using coding. The beautiful stats do it for us. So we're not going to waste our time on that. So, okay, you can run this. We got a green check mark. Again, we're just telling it that we want to not have nulls. The next thing we want to do is we want to, there's one other piece here we need to import. Let's try this. I have a feeling this isn't going to work. Sorry. I'm missing a piece. We're going to tell it where to look for the file. Again, because maybe it didn't remember the first time. All right, now we've got it loaded. File good. Go back to our handy dandy output here. Now we are going to define a correlation matrix. We're going to tell it from our coding, the variable, what it means. So we are going to paste this in here. Again, if you get a check mark, bingo, we're all good. All right, okay, now now that we've loaded our data file, we've told it, we've defined our correlation matrix. Now we're going to do the fun stuff. I'm going to show you how cool this is. Trust me. You don't get this in boring statistics packages, but this is why I love using Python, because we have smart people out there in the world who do shortcuts for us, and they're really great. Okay, so we are going to run that code, and it's going to give us a correlation matrix, just like you may have done in your statistics class in Excel, but look at how pretty this one is. This is a heat map. What I love about this is not only does it tell you over here, just like a regular correlation matrix, we look at one variable and we see the relationship with another variable. And so if we're looking at the variable survived, lived or died, it's going to be 100% related or correlated to the same variable. So in this case, what we are going to do is we are going to look at, there's something a little bit awry here, but let's pretend it's okay. What we are going to look at is the correlations between the variables that we have here. But let's do that in our worksheet. So this beautiful heat map correlation chart, which has the strongest correlation is always 1. Remember, 1-to-1 relationship, and a positive relationship, the stronger, the darker the red, a negative or inverse relationship, the cooler blue that becomes. So let's take a copy of this out of our Colob. Bye-bye, Colob. We're done with you for the day. We're going to paste this. And again, no likey. Okay, so we are going to paste this, and we are going to analyze the data that we have here. So what I want you to look at is, let's look at some of these, you take your handy dandy code sheet, you're going to look at some of these variables, and you're going to say, okay, there's a pretty high relationship right here, 0.41 between SP and Arch. So what does that mean? We have Arch is the number of parents and children the passengers had aboard the Titanic, is positively, moderately related to SBSP, which is the number of siblings or spouses the passenger had aboard. Okay, so that makes a lot of sense, right? So you have passengers with kids and passengers who had siblings. So of course, they're going to likely be related. And in this case, it is a positive relationship or association or correlation, whichever the 3 you want to say. Moderate, because it's not quite halfway there. So we're in sort of a orangish, but they are related. So let's take another one. Let's look at this one here. Adult male and whether they survived or not. Remember, we just looked at those in the account. So if you look at an adult male and it has a strong inverse relationship. So in this case, it is negative 0.56. So what this is telling us is that remember we had the zeros and the ones were the adult males, and the zeros were everyone else, the women and children. So the more the male, the more likely they are to die, an inverse relationship, because 0 is died and 1 is lived, and 0 is male and female. I'm sorry, 0 is women and children, and 1 is male. So the more likely, the higher the chance of being a male, the more chance you have to pass away. That's how you read the correlation chart. So now what I want you to do is I want you to go in and answer these questions. I want you to look at the correlation coefficient between class and fair. So these right in here, as I recalled, were the coefficients. Now what you have to tell me, if it is positive, you can just put like this one, 0.41. If it is a negative, you put a negative there. So I want you to go to the chart and tell me what the correlation coefficient is and describe that relationship for passenger class and fare. Next, I want the correlation between adult male and whether or not they're traveling alone. So again, how do you get these variable names from the chart? The handy dandy code book. This is why we go through the painstaking process of creating a code book, because we get mixed up and we can't remember all of it. Okay, so there you have it. The next thing I want you to do is I want you to list the two variable pairs with the strongest correlation and what their coefficient is. So look at the chart. Remember, the strongest is closest to 1 or closest to -1. So find the two, tell me what they are, give me their variable names and the coefficient, the top two. So the two strongest, the two second strongest, the coefficient. And we're done. You've successfully uploaded your file into Colab, or actually into Google Colab, Google Drive. We've run correlation using Python script, and we have analyzed the data. So bravo to you. And the best part about it is we didn't have to clean the data at all. Python did it for us. So this is the second of 3 worksheets that you're going to upload, including your Excel file, into the Titanic worksheet or assignment. So bon voyage, safe travels to all of you, and I will see you real soon with logistic regression for the Titanic, which we will have next. So bon voyage, everybody. Take care.